Welcome back to Calculus Universalis. Today we're digging into the formal definition of the definite integral, the key that connects Riemann sums to the exact area. You'll learn how to compute definite integrals using geometry, how to apply shortcut rules, and how to simplify problems using properties of integrals. These will save you tons of time on the AP exam. Let's go over what is a definite integral. The definite integral from a to b of a function is this. This represents the net area between the curve and the x-axis from x equals a to x equals b. The area above the x-axis is positive, and the area below the x-axis is negative. The result includes units if context is provided. Key properties of definite integrals are additivity. You can add integrals, and so an integral from a to b plus an integral from b to c equals the integral from a to c. You can reverse limits. So from b to a of a function equals the negative from a to b of that same function. So by putting a negative in front of the integral, you can flip the bounds of the limit. Zero width intervals, or any interval, or any it's just this. When it goes from a to a of a function, just gonna equal 0. And then a constant multiple a to b times k times your function equals k times the integral. So you can just pull the function out. So those are the major properties that are going to allow you to apply these rules while you're doing your integrals and help you a lot in simplification. So let's go over example 1. If we have an integral from 0 to 3, 6 minus 2x dx. Now using geometry, we can see that this is a straight line function, a triangle. At x equals 0, the height is 6. At x equals 3, the height is 0. So this forms a right triangle with base 3 and height 6. So our area is 9. So we sketched the function and figured out what it'll look like, and we're able to draw a triangle based off of it. Example number 2. If you're given the integral is 5, as well as from 3 to 6 of f of x equals -2, and then you want to find the integral from 1 to 6, you can just add these. If you want to find this, you can add these and it'll be 3 net area 3. Example number 3. Let's evaluate from -3 to 3 of x squared dx using symmetry. Since x squared isn't even symmetrical about the y-axis, we can double the integral from 0 to 3, find that to be 9, double it to get 18. So we can use symmetry to save time. Here's what to remember from today. Definite integral gives you net area between curve and x-axis. You can compute integrals using geometry or properties. You can learn shortcuts, flipping limits to add a minus sign, pull it out with a constant multiple. You can combine integrals and add them to add intervals together. And then symmetry of even and odd functions can simplify work. Some practice problems you can do are using geometry to evaluate integrals, use properties, and estimate using symmetry. Tomorrow, we'll start Fundamental Theorem of Calculus, Part 1, and then finally connect integrals to antiderivatives. You won't want to miss it. See you in Day 5.